Create a base class polygon with data fields, height, and width. A function named setValues is to assign the data field values. Derive two classes rectangle and triangle from polygon as base class, and a function named area to find area of rectangle or triangle. Use pointer to base class concept. Assign values, and print corresponding area. Here we go with the program code. I first declare the base class polygon. Since we will be inheriting this class, I would prefer declaring its data with scope of visibility as protected, and since this program is written to find the area of a rectangle or a triangle, I declare two variables, width and height. Just reminding you that area of a rectangle is width times height, and area of a triangle is half of width times height. We then set public visibility, and declare the function setValues, which assigns incoming values of a to width, and b to height. Next is declared the class rectangle. It inherits the class polygon. So these two classes are linked. The area function of this rectangle class returns the value of width times a height, which is the area of a rectangle. Next is declared the class triangle. It inherits the class polygon. So these two classes are linked together. Area function within this class returns the value of width times height, divided by 2, which is the area of a triangle. After these declarations, the program control shifts to line 25 in main function. An object, R, of the class rectangle is created. Since R inherits the class polygon, it comprises of all statements within polygon, and the statements within class rectangle. Then similarly, as on line 26 of program code, we create an object, T, of the class triangle. Since T inherits the class polygon, it comprises of all statements within polygon, and the statements within class triangle. On line 27, we instruct to create a pointer P1 that would point to the class polygon, and it would be assigned the address of object, R. Hence in effect, the pointer P1 would point to the object R, and since as declared, P1 is a pointer that basically points to the class polygon, within R, P1 would point to the block of statements related to class polygon. Likewise, on line 28, we instruct to create a pointer P2 pointing to the class polygon, that is assigned the address of object, T. Hence in effect, pointer P2 would point to the object T, and within it, P2 would point to the block of statements related to class polygon. Then on line 29 of the program code it is instructed that, from the location where pointer P1 is pointing to, execute the setValues function with parameter values 4 and 5. As per this function, width is assigned 4, and height is assigned 5, within this object, R. Similarly on line 30, the setValues function pointed by P2 is executed with parameters 5 and 10. So in this object T, width is assigned 5, and height is assigned 10. Then on line 31 of the program we first see out the message, area of rectangle. It's printed on output screen. Then we invoke the area function with an object, R. It computes the product of width and height, which is 4 times 5, or 20, and returns it to the calling part, from where it's printed onto the output screen. On line 32, the process flow is same as above. Area of triangle is printed first. Then it's computed via the t.area function. The computed value of width times height divided by 2, that is 5 times 10 divided by 2, or 25, is returned and printed on screen. The program ends. So what did we learn in this program? We learned to set a pointer to the base class, and assign it with reference address of the derived class as per lines 27 and 28. Then we executed the base class function using the pointer to base class, as in lines 29 and 30. Finally we invoked the functions in derived class, using the object reference as is normally done.